Hello guys, this is a linear motion experiment, and this procedure to do the linear motion experiment. We must prepare all the apparatus and calculate the glider and hanger. Let's go to the experiment. Firstly, put the mesh on the glider and put the mesh on the hanger. After that, switch on the wind machine and write the time. After finish, we calculate the data. Do it again in the same way on other attempt. And this is our result. Next is analyzing and discussion. For the first question is plot a graph weight force versus acceleration. Number 2 is what does the graph tell us? The graph of weight force versus acceleration shows an inverse relationship. As the weight force increases, the acceleration decreases. This trend is expected because in the experiment, adding more slotted weights not only increase the force pulling the system, but also increase the total mass being accelerated. As a result, the larger mass reduces the acceleration even with a greater applied force. Newton's second law given by F equal ma. Explain this behavior. Here, F is the weight force of the hanging mass. M is the total mass of the system, hanger plus slotted weights. And A is the acceleration. As the total mass of the system grows, the acceleration decreases because the system's ability to respond to the applied force is slowed down by the increasing mass. Number 3 is do this result supports Newton's second law? Yes, the results clearly supports Newton's second law. The data and graph align well with the equation F equal ma, showing how acceleration is affected by both the applied force and the total mass. For instance, when the weight force is small, 11.77 n, the acceleration is relatively high, 574.55 meter per second. However, as the weight force grows 17.66 n, the acceleration drops significantly to 65.31 meter per second. This makes sense as the increasing total mass reduces how efficiently the system accelerates, even with higher force applied. And number 4 is discuss any source of error. One of potential source of error is measurement inaccuracies in time, T or mass M1 and M2. Number 2 is air resistance or friction affecting the motion. Number 3 is uncertainty in the calculated value of acceleration, A equal to x divided by t square. Number 4 is parallax error in taking measurement. And for the last is conclusion. The conclusion for the experiment is the experiment likely supports Newton's second law, provided the graph shows a proportional relationship between F and A. Any deviation from a straight line could be attributed to experimental errors to uncounted forces. And this is the end of the experiment. That's all from us. Thank you.